Yeah, hi, so good evening everyone. I'm going to talk this evening about how I use PowerShell to automate the generation of a custom Wim for use with Mdt and SCCM deployments. My name's Paul Symonds. I'm an IT contractor. I've been doing it for a number of years now, mainly in the Win10 space with Active Directory, Group Policy, Office 365, Exchange, and so on and so forth. Tonight's talk is going to focus mainly on the bottom three on the list: Mdt, desktop deployment, and PowerShell, obviously. So, why use a custom Wim? There's a few reasons, but the first one is mainly the efficiency and time savings you can benefit from it. Because if you can inject some Windows updates or some middleware that every machine is going to use, you only install it once when you build the Wim, and then not every time you deploy a machine through a task sequence. I've also found that it helps you produce a cleaner image, particularly when you come to remove some of the modern apps from Windows 10. I found doing it online quite often errors with no apparent reason or useful error message. And it will help simplify your task sequence. Just by way of an example, the task sequence on the right hand, your left hand side is using the custom Wim, and you can see on the right hand side all the additional steps that need to be in a task sequence to get the same result using just the standard install Wim from a Windows 10 ISO. So why automate it? Apart from the obvious reason that because we can, it's partly because of the release cadence of Windows 10. Because back in Windows 7 days, you'd create your custom Wim, and that would be it. There'd be no. You'd maybe open it up every 3 to 6 months to inject some patches, so that your task sequence didn't spend hours doing Windows updates. But now with Windows 10, we've got 2 releases a year. So the creation of a custom Wim may become a repetitive task, and therefore a good candidate for automation. And secondly, for myself, as I'm a contractor, I work with multiple customers, so I may need to do this on more than one site. So what do we need to automate? First and foremost, we need a Windows 10 ISO to create our Wim from. You need a hypervisor of some sort. I've used Hyper-V just because it's in Windows and I have it. You need some sort of a deployment toolkit. SCCM could be an option, but Mdt, it's free, and it's generally a lot easier to use to create a task sequence. It does have a dependency, of the Windows Assessment and Deployment Toolkit, and this changes, or this is updated with every version of Windows that comes out. So each new version of Windows you want to deploy, you need to download the latest version of the ADK, possibly a later version of Mdt as well. You may want to add or remove some applications. So you might have some middleware that you want to deploy on every machine, or a particular version of Java. Or you might want to remove the modern apps from Windows. Like not every organization wants to use the built-in apps like Xbox and things like that. And it's good to have the latest Windows updates in your image at the time of building it. So how do I go about this? When I first started, I had one big long script to try and do everything, and I quickly realized that was the wrong way to go about it. Because there's a lot of different things to take into account, because we need to create virtual machines, we need to download applications, we need to configure deployment share, customize Mdt, and the list goes on. So I decided to write a bunch of helper functions. Hopefully from the names it's fairly explanatory what they do. And finally, to allow it to be as flexible as possible, I've made use of some configuration files, so you can choose which applications you want to install, which ones you want to remove, and any Windows features you want to install along with the operating system. Okay, so let's take a look at the script. The first thing we'll do is look at the help. Yeah. Okay. So the first bit basically talks about what I've just been talking about. We can see there's two parameters the script takes. The first one, the Mdt Deployment Share, is where we're going to build the deployment share, which is going to hold the operating system, the applications, and ultimately the custom Wim. The media location is the location of the ISO, and again, any applications, updates, and where it's going to store the virtual machine that gets created. Okay, so the first thing it does, the parameter checks that you actually have an ISO where in your share, because you can't build an image without one. So if you go to a share that doesn't have an ISO in it, the script's not even going to bother running. Then we do a couple of checks that you need to run as administrator to perform this, to run the script, and you need to have the Mdt workbench installed. So that's just checking a registry key is present and importing the module from the location it finds in the registry. Then I go on to set a couple of variables. Yes, yeah, sure. Is that better? So set a few variables, and then, although I won't do this now, I can't dot source the helper scripts because I'm not running the script as a script. So I've manually loaded each function into memory ahead of doing this. So the first thing we're going to do is select which ISO we need to use for our image. This folder happens to have more than one ISO in it, so you have to just choose which one you want. And now Windows 10 comes in many different flavors, so again we need to choose which version we wish to deploy. So Windows 10 Enterprise is probably going to be the most common one. Once we've chosen that, we can configure our VM. We create our VM to build the image on by calling the configure VM function. And all that is doing is just creating a new switch. And we need the MAC address for later on in the MDC configuration, so we pass that back to the script. And then we configure our machine with some memory, a CD drive, so we can mount our ISO later on, a VHD. And one thing that threw me for a little while was that when you boot up your virtual machine, it has to have a static IP address to connect to the deployment share. It doesn't do it if it's got the DHCP address for some reason. So it took me a while to figure this out. So my solution was to find out the address that the switch had been given and add 1 to the last octet to use as a static IP address for the virtual machine. And I'll just check here. If it does give you an invalid IP address, just make it a valid one. There may be a more elegant way of doing this, but that's how I got around it. And as we can see down at the bottom, we've got an IP address of 169.254.27.27 and 169.254.27.28. Once we've got our virtual machine created, we'll check if any applications from our spreadsheet need to be downloaded or if they're already in the media folder. I've pre-downloaded them just to save a bit of time. Actually, I'll just show the spreadsheet first. So this image is going to install all these versions of C++ on the machine, Microsoft Silverlight and .NET. Just as an example. And each application requires a silent switch to be used within a task sequence. And they just get all downloaded into here. So once we've got our applications, we'll then download the latest cumulative updates. I won't spend too much time talking about this because this is actually a function written by, what's his name? Aaron Parker. I don't know if some of you may be familiar with his work. He runs a Stealth Puppy blog. He's written a function does a JSON query to find the latest Windows update and download it. So rather than reinventing the wheel, I've just used that. And we're also going to create a local user account on the machine so that the virtual machine can connect back to the deployment share using these credentials. And as I said earlier, sorry Ryan, it's got a plain text password. That's purely because MDT stores it in a text file in plain text. So in the function that creates the user account, obviously it has to get created to a secure string to create the user account. And I've just on the off chance that you happen to have a username called Mdt-capture, if it already exists, the script will just create another one with a random number on the end. So you don't overwrite any existing users. So once all that's done, we can then move on to create our deployment share and import our bits and pieces. I'll just run this because it takes a bit of time, and then I'll talk a bit more about it. Oops. I didn't, did I? No. Maybe I've bitten off more than I can chew. So the first thing we're going to do is create our Mdt deployment share in the location we specified in the parameters, which by default is C Mdt capture. It will overwrite an existing folder structure, so just be careful if you do use this. We then import the module from Mdt module and create a new PS drive. I've probably already got one created because I ran it earlier. We need to set a few permissions on the drive so that the local account we've created has permissions to write the WIM into the captures folder. It's going to find a file specified. Okay, this isn't going as well as I hoped. But once we've done the import, once we've created the deployment share, we'll then import our operating system from the ISO we selected earlier, import the cumulative updates, create a standard task sequence with no additional configuration in it, and then import each one of the applications from the CSV file into Mdt. And once that's done, we need to configure the bootstrap ini and custom settings ini file, which is what Mdt uses for its configuration. So in this first setting, we've got our static IP address and subnet mask from the VM. We're setting our deployment route to the Mdt share using the username and password that we created earlier. And the custom settings ini file can contain a whole host of different items. Most of these are to skip pages in the welcome wizard so you can run it silently. Any pages you do skip, you need to provide the information that would be on those pages, such as the key input locale, UI language, what your task sequence ID is going to be, and so on and so forth. Once that's done, if we've defined any OS features in our OS features config file, they will be added onto the Mdt share. The custom settings ini file. And to save us having to mess around with XML in the task sequence, fortunately, we're able to add mandatory applications into the custom settings ini. But one thing I did find out is no, that's not this section. So again, we're just taking our list of applications, finding the application ID is GUID, and adding it to the end of the custom settings, which I don't think I can show you, unfortunately. Damn. So once that's done, we're ready to update our deployment share to create our boot media. Before doing that, there's a couple of little things that need to be done. We need to remove the Mdt components from WinPE, as it's a known bug with Mdt that this can cause issues with SSDs. And we set the driver injection selection profile to nothing, so we prevent the cumulative update from being ejected into WinPE boot image and potentially bloating it, and it may not load. This is done in the settings XML file, which I found out doesn't exist until you open the console. So this section is just open the console, then closing it again, just to generate the file. Then we use the XML commands just to modify our selections and save it back. Once we've done that, we can then update the boot media and generate our ISOs, which takes a fair bit of time. So once that's done, the x86 ISO is then added to our virtual machine. The machine is started, and a reference image is generated. So this whole process end to end takes about 90 minutes to 115 minutes in my testing. So obviously can't show it end to end. I've done a few screenshots of.
What made you decide to use Mdt rather than DSE and Ability?
I had Mdt and Hyper-V on my laptop at the time. I haven't looked at mobility much. Ability, sorry.
Yeah.
I haven't used it at all, really. So. Okay, so the VM is just going to spin up, it's going to format the disks, it's going to install the operating system, it's going to install all the applications, it's going to sysprep the machine to remove any identifying properties from it, and then it's going to create the WIM file and save it in our deployment share. After doing that, it's going to then mount the WIM file and remove any applications that are specified in the apps to remove text list. And once it's done that, You get a nice little script summary of the actions it took, how long it took as well. So after creating the custom Wim, I then did a comparison of deploying the custom Wim against deploying the task sequence that did all the application installs, all the updates, and removing the applications. And I found on average, just deploy a vanilla task sequence doing nothing else, no domain join, no BitLocker, any other apps or anything, was about 16 minutes using a custom Wim. And using a default Wim with all the other bits and pieces in it was 27 minutes, so 11 minutes per machine. So you can see if you're building 100, 200 machines, there's a decent time saving there. The customized Wim task sequence is easier to read. The other one has more steps in it to do all the other bits and pieces that are in the custom Wim. And the cleaner image, the offline removal tends to work a lot better, I found, than online removal. So from the log file that the remove appx packages file generates, you can see that offline they're all successful. Doing the same thing online, there's a number of errors and things do not get removed with no clear reason as to why. My guess would be that files are in use and things. All right, so thank you very much, and any questions?